In the previous lecture, auto mesh, advanced mesh, manual mesh, and remesh were introduced. In this lecture, let me talk about the pre-processing and post-processing of the mesher. These are the main pre-processing functions of mesher. Delete geometry and fill hole functions remove the shapes that reduces mesh quality and that can also be ignored in actual simulation. Imprint is a function that specifies in advance the locations where the nodes must be created. Geometry refinement is a function that controls the precision of the tessellation data for AutoMesh. As you can see, delete edge is used to remove unnecessary edge. Fill hole is a function that fills unnecessary holes. Let me show you one example of delete geometry. This body has several holes. If you mesh this body, like this, very small elements are created around the holes. However, in some cases, this kind of holes just degrade the mesh quality and make the simulation time longer. In that case, you need to fill these kind of holes before meshing the body. To remove these holes, click Delete Face on the Geometry tab and select Holes. If you click Search, holes are automatically selected. Click OK, then holes are removed. After that, if you create a mesh again, a uniform mesh is created. Imprint is a function that specifies the locations where nodes must be created when creating a mesh. You can specify points or lines to create nodes along this line. Please note that there are imprint functions in mesher and other imprint functions also exist in the Geometry tab. For the body above, I will create a mesh without any imprint. Then I will mesh the below body using imprint. Select the cylinder as the target geometry and the diagonal surface as the tool geometry. You can see that the intersection area is imprinted to the target body. Now, if you mesh this imprinted body with AutoMesh, nodes are created along the imprinted line. Geo-refinement was mentioned when I introduced AutoMesh. This is a pre-processing function that can be used for AutoMesh only. This dialog box allows you to adjust the precision of the tessellation data to be used for AutoMesh. I think you can use it easily because the parameters are similar to the ones of surface patch of contact dialog. This time, let's take a look at the post-processing features of the mesher. Quality check is used to confirm the quality of the mesh. Split shell 4, combine shell 3, node merge are used to combine or split elements or nodes. Flex merge merges two meshes into one mesh. Quality check highlights the elements that violate given conditions. Using this, it is possible to judge the quality of the mesh and improve them as needed. In this image, elements whose aspect ratio are greater than 3 are highlighted in yellow. Node merge is a function that merges two nodes into one. When nodes are merged, elements are merged accordingly. If two nodes are very adjacent, it means the quality of the element is poor, so it may be better to merge those nodes. Combine shell 3 makes two shell 3 elements into one shell 4, and split shell 4 divides one shell 4 into two shell 3 elements. These are also used to improve the mesh quality when there are poor quality elements. Flex merge is a function that merges two meshes into one mesh. At this time, the nodes of the connection part must exactly match. When two meshes are combined into one mesh, nodes of the connection part belonging to each mesh are merged. Two meshes are eventually merged into one. I will merge these two flexible bodies into one flexible body. First of all, since the left side and right side of the bodies are fixed, non-fixed area of each body will be deformed. As you can see, the ends of both bodies in the middle are off. Now, I will use the merge function to merge these two bodies. Specify one as source and the other as target. Then it becomes one flexible body. Imagine that as if the nodes in the middle are affixed. See? The nodes in the middle are affixed. Assist modeling is actually a very important function. Fortunately, you don't need to worry about this because it works automatically in RecurDyn. Usually, RecurDyn users convert rigid bodies with joints, forces, or contacts to flexible bodies. When a rigid body is converted into a flexible body, the original joints, forces, and contacts attached to the rigid body must be preserved when being converted to a flexible body. At this time, for joint and force, FDR must be created in the connection position, and for contact, patch set is necessary. When RecurDyn converts a rigid body to a flexible body, RecurDyn recognizes the joint, force, contact, and related information. Then, RecurDyn automatically creates FDRs and patch sets using that information, and they are used to preserve joint, force, and contact. As shown in this video, if you open the Assist Modeling dialog box in Measure mode, you can understand where FDRs and patch sets will be created. In some cases, users may need to modify surfaces or solids to create FDRs or patch sets properly, but this is much easier compared to the manual creation of FDRs and patch sets. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.